This video is going to talk about elements of the scientific method. So we're going to look at how scientists approach the scientific method and experimentation. The first question we're going to ask ourselves is science a linear process, and is the scientific method a linear process? And the answer to that is both yes and no. So you can follow a linear process to solve many simple experiments or simple scientific phenomena. And because of this, we often start teaching the scientific method as linear. So it's 1, 2, 3, 4, and that's how it's always going to work. But as we move up through science and science becomes more complicated, it becomes clear that science is no longer a linear process because something isn't working correctly. We're going to have to change something. We're going to have to get kicked back into a earlier step of that scientific method to see how things are working. So typically we're going to approach the scientific method in a more cyclical fashion as we move through science and science becomes more complicated. So we're going to observe, we're going to question, we're going to then formulate hypothesis, we're going to develop testable predictions and gather data. But after we gather data, we might have to refine, alter, expand, or reject our hypothesis, which puts us back at the testing phase. Then we're going to gather more data. If that data is giving us concrete conclusions, we can then develop conclusions, and from those conclusions, scientists can develop general theories. The first step, or where we're going to enter this cycle, is we're going to observe. What do you notice? What is happening? What do you notice about the world? What do you notice about a specific event? And from those observations, you're going to ask questions. Why does this happen? Why is this specific event happening? Why does it happen in a certain manner? Those questions are going to lead into a hypothesis. So you're going to formulate a hypothesis. If I do this, then that will happen. If this happens in an event, then this is the result. And that hypothesis is going to help you to develop testable predictions. So how am I going to test my hypothesis? How am I going to get those results? Because remember, scientists want other people to be able to recreate their experiments and come up with the same conclusion that they did. Once you've developed those predictions, you're going to experiment and gather data. So what data are you getting from your experiment? What is your experimentation telling you? From there, you may have to refine, alter, expand, or reject a hypothesis, because that data can be all over the map. So was my original hypothesis specific enough? Do I need to change something in my hypothesis? Maybe I noticed that there was something that was off, and with a simple change, then I can get much better data. Was my original hypothesis too specific? Maybe I need to be looking at something more broad, or maybe my hypothesis was way too off base and I need to change it and start over. Once I've tested a change in hypothesis, I'm going to look at that data and I'm going to develop conclusions. So what have I learned from my experiments? How did changing my hypothesis change my results? And last, we're going to develop general theories. So what did my conclusions tell me? And if they told me something amazing, I can put that in a scientific article and publish it. And then I move on to making another observation and asking another question, because science is a never-ending process.